Hi, Connie. How are
Hi, good
you? Good to
morning.
see you. Good morning. 早上好. So I'm going to go straight to the lecture now. Okay, now this time we have absolute value here is greater than or equal to 3. Okay, before was less than or equal to 3. This time is greater than or equal to 3. Okay, let's think about is if the absolute value of x here is greater than 3. Remember this represent the distance from 0. So distance from 0 over here is, what does it say here? This space is greater than 3 units, right? It's greater than 3 units. So first I'll locate the two number. Comparing to 3, x is bigger or smaller?
Greater? Bigger?
It's greater. Yeah, x is greater than 3 because on the right side. Okay, so the solution, so if you go here, that will satisfy, is here also satisfy. So this is our all. It cannot be less than negative 3 and greater than 3 at the same time. So this absolute value inequality right here is going to break down into this right here. So we can remove this absolute value and then we say whatever inside, that will be either less than negative 3 or greater than 3. Could be over here, could be over here. So that will be the solution. Okay. Okay, now the next one here. If it's greater than or equal to 5, so we're going to locate the two numbers. So we're going to locate negative 5 and 5. So where are those x located? This x over here, where does it locate? Should that be the inside? Should that be this inside over here? Or this outside over here?
Outside.
Outside. You want it to be greater than or equal to 5 units away from 0. So you want to be further away from 0, right? So it will be over here or over here. Okay, not the inside. Okay, should I include this 5 or negative 5? Should I include this two endpoint?
Yes.
Yes, I hear you loud and clear. Okay, so yes, because that has an equal sign right here. So we'll include this n equal to 5 or negative 5 are okay. So x could be either over here or over here. So if it's over here, then x is less than or equal to negative 5. If it's over here, then x over here will be greater than or equal to 5. So this is all statement. So break it into this one. Got it? Okay. Now some students put it this way. Tell me what's wrong. This is not right. What's wrong?
It's saying less than 5.
Yeah. The x here, well, some say, well, x is greater than or equal to 5, right? And then if put x is less than or equal to negative 5. But this one here is not right. It cannot be greater than 5. It cannot be greater than 5 and less than negative 5 at the same time. That doesn't make sense. Okay. So this one cannot. Okay. And also this implies that negative 5 is actually greater or equal to 5. Because by transition, negative 5 greater or equal to x and x greater or equal to 5, that implies negative 5 greater than or equal to 5, which is wrong. Okay, that's impossible. Okay, so don't do it this way. Okay, it's not right. So this one is right. Okay. Okay, now let's try to solve this one over here. Okay. So over here, we're trying to solve this inequality, absolute value inequality. So let's think about it on the number 9 over here. So we're going to locate what are the two numbers. We're going to locate negative 6 and 6. So if, in your mind, you can try to imagine that two number. Okay. Now think about this whole expression inside. If it represent a single number, okay. So will be the inside or the outside right here. It'll be close to 0 or further away from 0. Which one? Is
Outside.
this is outside because you want it to be greater equal 6, right? So it's outside. So it should be either over here, including this, or over here, including this end. Okay. Now, if it's over here, then you have this expression that is going to be less than or equal to this negative 6. If it's over here, then you have this 3 minus x over 5 that will be greater than or equal to 6. Now we just need to solve each one of them separately, right? Okay. To solve this one over here, what should I do?
Multiply by 5.
Multiply by 5. So you get 3 minus x less than or equal to negative 30. And then subtract 3 from both sides. Negative x less than negative 33. Divide both sides by negative 1 or multiply by negative 1. You need to switch inequality sign. So x is greater than or equal to 33. What about this one? Similar, right? So we will multiply by 5 on both sides. Okay. So 3 minus x greater equal to 30. Subtract 3 on both sides. X greater than or equal to 27. Times negative 1 on both sides. We switch this inequality sign. X less than or equal to negative 27. Right? Now let's graph them. Graph the solution set. So here's the number 9. So locate negative 27. X is less than or equal to negative 27. So it will be over here. Or x is greater than or equal to 33. So over here. So how should I write the solution set? This part here will be what? Negative infinity to negative 27 bracket, right? This part here is bracket 33 to infinity parenthesis. Now they don't overlap, right? Either part is okay, right? Either this or this is okay. So over here we put union. So it's the use right here. It stands for union. So that will be the interval for the solution set. You good? Are you guys good?
Yeah.
This one here, yeah, it's one of the challenge. So I try to make it easy so that you can visualize it. Okay. So it's actually if you can visualize this, the outside here, then you just put whatever this expression here, and then less than equal to this number, and then this one greater than equal to this number. Okay. So that is going to be make it easy for you if you can visualize it in your mind. Okay, so remember, if it's less than or equal to absolute value of that less than or equal to 3, then this one over here will locate. We're going to locate this on the number line over here. We're going to locate the two numbers. One it is negative 3. The other one is 3. Then this package, whatever expression that's inside, will be the inside in between. So greater than or equal to negative 3, less than or equal to 3. Okay. Now, if this is the greater than or equal sign right here, then you also locate the two numbers, this negative 3 and 3, but this time will be over here because you want to be further away from 0, over here or here. So whatever expression that you take absolute value, then that's less than or equal to this negative 3 or greater than or equal to 3. So it depends on this inequality sign here. But now I'm going to summarize. Okay, summarize the one that we talked about today. Okay, so absolute value of a quantity equal to 3, then that quantity is equal to what? Can someone tell me? So that will be equal to?
Is it negative 3?
Positive or negative 3. You got it.
Right.
Okay, positive and negative 3. Okay. Now, what about if absolute value of this is less than or equal to 3? So what can we say about that quantity?
It could be any number.
Greater than or equal to -3 and less than or equal to 3, right? So it's going to be in between, which is this one, right? Remember? Okay, which is this case right here. Well, if it's greater than or equal to 3, that will be this case over here, right? So either this one or this one. So you're going to have this absolute value of that. So you have this is going to be less than or equal to -3, or here that will be greater than or equal to. So which is this one? Now let's solve this one here. This will be the last one. Okay, so we're going to solve this absolute value inequality. So what would you like to do first? You cannot distribute. Be careful. You cannot distribute that inside the absolute value. It's very dangerous. This is the absolute value bomb. Okay, don't do anything inside, especially when you have this negative number. When you distribute, you're going to get an error. Okay, so don't touch it. Try to isolate that. Okay, so to isolate this absolute value, we need to undo this multiplication. Okay, so to undo this multiplication, we divide. So we divide both sides by -2. Remember, divide by negative quantity, the same negative quantity on both sides. You need to switch this inequality side. So erase and switch it. So it goes this way. Switch. Divide by -2, switch inequality sign. Now, by doing this, then we're going to have this divide out, right? Okay. So you have this absolute value of x minus 5 that's greater than or equal to positive 4. Okay. Now you can try to imagine this number 9 in your mind. Okay. So you locate the two numbers. So which is -4 and 4 should be the inside or the outside?
Outside.
Outside. Yes, it's the outside. So over here or over here. So in your mind, you imagine this, either this part or this part right here. Okay. Now, so this package, think about this as a package. Okay, will be either over here or over here. If it's over here, then you're gonna get x minus 5. It is less than or equal to -4. If it's over here, you have this x minus 5. It is going to be greater than or equal to 4 because it's on the right side of. Now you solve this by adding 5 to both sides. So x is going to be less than or equal to 1. And this one here, x is greater than or equal to 9. So the graph of this, okay, so let's locate the 1 and the 9 over here. X is less than or equal to 1 will be over here, including 1. Greater or equal to 9 will be on this side. So -infinity to 1, bracket, union, bracket, 9 to infinity. You got it? Okay, good job. Okay, so that's the end for today. You guys did a good job.
Much, Professor.
Okay, no problem.
All right,
Take
have a good
care,
one.
okay?